All right, get ready because we're going deep today.
The deep dive.
Yeah, a
Yeah.
deep dive into some pretty fascinating research papers
Yeah.
that you sent our way, actually.
Always love these.
The Google File System from back in 2003,
Mm-hmm.
and the Hadoop Distributed File System from 2009.
Classic papers.
Yeah, these are like blueprints
Blueprints.
for how the big guys,
Giants.
yeah, Google and Yahoo, how they handle just mountains of data.
Oh, yeah.
Unbelievable amounts of data.
Petabytes.
Petabytes, yeah.
Yeah.
We're talking like
all the libraries in the world.
I was going to say, but
Things.
digitized.
But digitized.
It's insane.
Yeah, it's mind-boggling.
And what's so interesting is both these papers,
Yeah.
even though they're a few years apart, they both focus on this
this core problem.
yeah, this huge problem.
The data deluge?
Of data, yeah.
Just this massive influx of data?
Like they knew this was coming.
Oh, yeah, they saw it.
And that the old ways,
Traditional file systems.
yes, weren't going to cut it.
Not even close.
Yeah, so they needed
They needed a whole new way of thinking.
a whole new way of thinking about it.
About storage and processing.
Right, but they each
Yeah, you had their own angles.
got their own angles on it, right? Like they
came
had
out the state.
specific needs
It
that
drove these solutions.
drove these solutions, yeah.
Totally.
So what were those, like what was Google dealing with specifically?
So the GFS paper,
Google File System.
Google File System, GFS for short,
Mhm.
they were talking about search and indexing.
Okay.
They needed to handle like crawling the entire web
Oh, wow.
and storing all that data.
Back then, even,
Yeah.
it's crazy, the scale.
Oh, it's mind-boggling.
That
Even
big.
back then.
So GFS was all about,
Organizing the world's information.
yeah, essentially.
Pretty much.
Yeah. But what about Yahoo?
Totally different.
Totally different.
Totally different.
Okay.
So their paper,
The Hadoop Distributed File System?
HDFS,
Yeah.
they were talking about things like web mapping and
Yeah.
analyzing user behavior.
Got it.
So they needed to process
Yeah.
all this information efficiently.
And the old?
The traditional file systems
Up to it.
just couldn't handle it.
No.
The scale was too much.
So we've got these two giants
Yeah.
facing this like
Tsunami of data.
tsunami of data, yeah.
Yeah.
But how did they actually deal with it?
Well, they both realized
Mm-hmm.
that traditional approaches
Yeah.
to file systems
Yeah.
had a lot of limitations
Oh.
when it came to handling these massive data sets
Okay.
spread across many machines.
They needed like a brand new approach.
They needed something completely new,
Yeah.
and it led to some really revolutionary ideas.
All right, I'm hooked.
Let's dive in.
Let's start with GFS.
Okay.
What was their like secret sauce?
Okay, so one of the core ideas in GFS
Mhm.
is the concept of
Okay.
a single master server.
Oh, I know what you're thinking.
Single point of failure.
Yeah, like that's risky.
It sounds scary.
Right.
But hold on, it's not as bad as it sounds.
Right.
The master server in GFS,
Yeah.
it doesn't actually handle the data.
So if it's not handling the data,
Right.
like what is it doing?
Think of it like a librarian.
Okay.
It keeps track of where all the books are,
Okay.
or in this case, data chunks,
Data chunks.
across this vast network of chunk servers.
So the master server is the brain?
It's the organizer.
Yeah.
It knows where everything is.
Yeah. Okay. And the chunk servers are the ones that...
They hold the actual data,
Okay. Got it.
but what's a chunk?
Yeah. What's a chunk?
A chunk is a big piece of data,
Okay.
64 megabytes.
64 megabytes.
Yeah.
That's huge.
That's massive.
compared to a traditional file system.
Oh, yeah.
What's the thinking there?
So with bigger chunks,
Okay.
the chunk servers
Yeah.
don't need to constantly check in.
With the master.
With the master,
Okay.
less communication.
So less back and forth.
Exactly.
Okay.
Makes the whole system faster.
Especially for those like big reads.
Sequential reads.
Yeah. That Google
Mhm.
needs.
Exactly what Google needs.
So it's like reducing traffic
Less chatter.
by sending bigger packages less often.
Exactly.
But what if you have a ton of small files?
Ah, you're sharp.
Yeah.
in picking up on it.
Yeah, that seems like a bottleneck.
That was one of the challenges.
Yeah.
Especially with things like executable files
Right.
that many machines need access
Right.
if everyone's hitting the same chunk server.
Yeah, it's going to slow down.
It's a problem.
Right.
So Google came up with some solutions.
Okay.
They started replicating popular files more often,
Okay.
and they staggered application start times.
So basically they tweaked the system
And adapted.
to handle those
Specific work.
their specific needs. Yeah.
Exactly.
Okay, and there's
There's another really interesting aspect.
like a cool little trick
Yeah.
that they did.
How they handle metadata.
Oh.
So all that information about files.
Permissions, locations, all that.
Okay.
They keep it all in memory.
Okay, but keeping it all in memory, doesn't that
You're thinking,
limit the size?
yeah, the size of the file system.
Yeah.
It's a good point.
Right.
But because the chunks are so big,
Okay.
they need relatively little metadata
Okay.
per byte of data.
Interesting.
Plus, they log all the changes to disk,
Okay.
just in case.
It's like a backup
It's
plan
a safety net.
for the backup plan.
Exactly.
But wouldn't that be more complex?
Well, the Google paper says that adding RAM to the master server was a small price to pay for the speed and simplicity
they got from that approach.
Exactly.
Interesting trade-off.
It made sense for them.
Yeah. So GFS is all about speed, efficiency, and some clever tricks. To deal with those small file issues.
Yeah, those little hiccups.
Now I'm curious to hear about Yahoo.
Yeah.
HDFS.
Okay.
Different set of priorities. Oh, yeah, totally a different approach.
Right.
Yeah. So while GFS was all about speed for Google's needs, HDFS was obsessed with something else.
Okay, what's that?
Data durability.
Data durability. What does that even mean?
Basically, they wanted to make sure your data is safe.
Okay.
Even if, and this is the kicker, even if the hardware fails.
Wait.
Constant hardware failures.
Constant failures, like servers bursting into flames?
Not quite that dramatic.
Okay.
But when you're building systems with thousands of cheat hard drives, failures are just a fact of life.
Okay.
Disks die, power supplies go out.
Yeah.
Things happen.
Things happen.
They knew they couldn't prevent it.
Right.
So they designed HDFS to handle it.
To just gracefully deal with these failures.
Yeah, gracefully.
Okay, so if failures are inevitable, how do you even begin to protect the data?
That's where HDFS gets really interesting.
Okay.
We'll unpack all of that right after this.
Okay, so we left off with
constant failures.
This idea of constant hardware failures.
Right.
And Yahoo, like obsession with
data durability.
Data durability, yeah.
Yeah, keeping that data safe.
So how do they actually pull it off?
So one of their key strategies is replication.
Okay.
But they take it a step further.
Okay.
They actually verify the data
every time it's
read.
Wow.
Using something called checksums.
Checksums, yeah.
Yeah.
I vaguely remember that.
From networking class.
Yeah. Something about
error detection.
Error detection, right.
It's like a fingerprint.
Okay.
For the data.
Okay.
So when a file is written, a checksum is calculated.
For each block.
For each block of data.
Okay.
Then whenever that data is read, the checksum is calculated again.
Okay.
And compared to the original.
Okay.
If they don't match.
Yeah. Then you know something's wrong.
Something's up.
Corrupted data, potentially.
It's like corrupted, yeah.
It's like a built-in alarm system.
Yeah, like a little tripwire.
That goes off.
Yeah.
If the data's been tampered with.
Exactly.
Clever, but wouldn't checking the checksum every time?
You're thinking.
Yeah, wouldn't that add a lot of overhead?
There is a performance trade-off.
Right.
You're right.
Yeah.
But for Yahoo, that peace of mind was worth it.
Yeah, they were dealing with some pretty important data.
Oh, this was critical data.
Yeah, user logs, web maps.
All sorts of valuable information.
Yeah, they couldn't afford to have bad data.
No, they couldn't.
Slipping through the tracks.
No.
So for them, ensuring data integrity
paramount
was the top priority.
Absolutely.
But checksums are just
one piece of the puzzle.
Yeah, one piece of the puzzle, right? What else did they do?
Okay, so another fascinating concept in HDFS is rack awareness.
Rack awareness. It sounds like my cat.
What do you mean?
Like when she knows it's time for her flea medication.
Okay, well, maybe she's onto something.
Okay.
So remember the chunk servers?
Yeah, the ones that store the data?
Yeah. Exactly. Yeah. In large data centers.
Yeah.
These servers are organized into racks.
Okay.
HDFS takes this layout into account when replicating data blocks.
So rack awareness means?
It means that when they replicate a block, they try to put those copies on different racks.
Okay.
So if an entire rack goes down,
oh, I see.
You don't lose all the copies.
Like a power outage or something?
Like a power outage or a network switch failure.
Okay.
It's a way of spreading the risk.
Right.
Preventing a single point of failure. From taking down your whole data set.
That's some serious
risk management.
Risk management, yeah. So they're not just replicating.
Right.
They're like strategically
distributing it to minimize the impact of failures.
Wow. You weren't kidding when you said they were obsessed?
Obsessed with data durability.
That's the durability.
Yeah.
And it doesn't stop there.
Oh, no.
Right.
They also have detailed processes
for
decommissioning nodes. Taking a server out of service and even handling upgrades
to the whole system,
to the HDFS system itself.
Wow.
They take snapshots,
Okay.
carefully move data around,
Okay.
make sure everything is in sync.
So they really thought of everything.
They really did.
But with all this focus on durability,
Yeah.
did they make any sacrifices?
In terms of in terms of performance?
Yeah. They do acknowledge some trade-offs
Okay.
in the HDFS paper.
Yeah.
They talk about challenges with small files
Okay.
and random access patterns.
Okay.
They even have a tool called the balancer
Okay.
to make sure data is evenly distributed
Oh, good.
across all the chunk servers.
We've got these two giants,
Yeah.
Google and Yahoo,
GFS and HDFS.
both tackling the same problem.
The data deluge.
But with
different approaches and different priorities.
Totally.
But they both built systems that could handle
massive amounts of data.
That's enormous amounts of data.
Absolutely.
And they both really changed the way we think about
They had a huge impact
data
on how we think about data today.
All right, I'm ready for the final showdown.
Okay, let's do it.
GFS versus HDFS.
Head to head.
Yeah, what are the key
similarities and differences
that really make them stand out? Okay, so final showdown time, right?
It is, yeah.
GFS versus HDFS.
Head to head.
What are the key similarities and differences?
Okay, so both systems share a similar architecture at their core.
Okay.
They both rely on a single master server to manage everything.
Yeah.
The master in GFS and the name node in HDFS.
Yeah, the central brain that keeps track of everything.
Exactly, knows where all the data is.
Right, and how to access it.
Yeah, and they both use replication.
Right, to protect against data loss.
Oh, yeah, I got to have those copies.
Yeah, you got to make copies.
Spread them across multiple machines.
Right. So
you're dealing with thousands of machines.
Statistically speaking, some of them are going to fail.
Oh, some of them are definitely going to fail.
Yeah.
But that's where the similarities end.
Okay.
When it comes to handling consistency.
Oh, okay.
GFS and HDFS.
Yeah.
They take very different approaches.
Okay, consistency. What do we even mean by that here?
So consistency in simple terms.
Yeah.
It refers to how up-to-date the data is.
Okay.
Across the whole system.
Got it.
So GFS, they prioritize speed and efficiency.
Okay.
Even if it means sacrificing a little bit of consistency.
So they're okay with things being a little out of sync.
Yeah, temporary.
As long as things keep moving fast.
Exactly, keep things moving.
Quiet.
They recognized that for their use cases, strict consistency wasn't always necessary.
Okay.
They built mechanisms into their applications to handle those occasional inconsistencies.
Okay, interesting.
HDFS, on the other hand, they take a much stricter approach to consistency.
Okay.
Remember those checksums?
Yeah, they calculate them on every read.
Every single read.
Wow.
That's a big part of it.
Okay.
They want to make absolutely sure that the data you're reading is accurate.
Makes sense given their focus on data durability.
It all ties together.
So GFS is the speed demon.
Yeah, like a race car.
Optimized for Google.
Exactly.
And HDFS is the
rock solid.
Yeah, the one you can depend on.
The reliable one.
Yeah.
Absolutely.
Interesting.
And those priorities,
they're
reflected in other choices too.
Okay.
So HDFS, you can actually tune the block size.
Oh, wow.
For different files.
Interesting.
More flexibility.
Okay.
And their rack awareness strategy.
Yeah, spreading the data across those different racks.
Exactly, minimizing the impact of failures.
It all comes back to that.
It all comes back to durability.
So there's no clear winner here.
It depends.
Depends what you need.
What are your priorities?
Right. What are you trying to achieve?
Exactly.
Both of these systems were like groundbreaking.
Oh, yeah. They were ahead of their time.
Yeah, for their time, really pushed the boundary.
Pushed the boundaries, yeah.
And paved the way for everything we're seeing today.
For the big data revelation.
Yeah.
Absolutely.
So what can we learn
from these giants?
From these giants, yeah. What are the key takeaways?
So even if you're working on a smaller scale.
Yeah, most of us are.
Yeah.
Right.
These papers offer valuable lessons.
Okay.
They teach us to think about data durability.
Yeah.
Especially now with hardware.
It's getting cheaper.
Getting cheaper, but also more prone to failure.
Yeah. Yeah. It's like you can't escape it.
You can't escape it. Failures happen.
Right.
And they make us think about the trade-offs between consistency, performance, and complexity.
Right.
And they show us the value of designing systems.
For their specific workloads.
Exactly. Optimized for what you need.
Yeah. It's like we get to look inside the minds.
Of these brilliant engineers.
These brilliant engineers. Yeah. Who solved these really tough problems.
Really tough data problems.
Yeah, we can learn so much.
Absolutely.
From their approaches, their successes, their mistakes.
It's all valuable.
And they remind us that the world of data...
It's always changing.
It's always evolving, always changing, yeah.
The challenges are different today.
Right.
But the principles...
The principles are still the same.
They're still there.
So what does this all mean for you?
That's the question.
Yeah, we've explored GFS and HDFS.
The titans of data storage.
Yeah, we saw how they tackled these huge problems.
The data deluge.
And paved the way.
For the big data era.
But the journey doesn't end here.
No, it doesn't.
What sparked your curiosity?
Yeah, what are you thinking about now?
What questions are you left with?
Yeah.
If you were designing a file system today...
Oh, that's a good one.
What would you borrow from these giants?
Yeah.
And what would you do differently?
That's something to ponder.
That's something to ponder. Happy deep diving.